Hi class, this is section 1.1 linear equations, part 1. An equation in one variable is a statement in which two expressions, at least one containing the variable, are equal. An equation is either true or false, depending on the value of the variable. The solutions or roots of an equation are the value or values of the variable that make the statement true. Example 1, solve the equations. Okay, so for part A, I'll start by adding x to both sides of the equation. On the left-hand side, I'll have a 3x. So 3x minus 6 is equal to 3. I'll add 6 to both sides. Then I have 3x is equal to 9. Divide both sides by 3. And I come up with x is equal to 3. I can check this quickly by plugging a 3 in for the x's. So 3 times 2 is 6 minus 6, and I'm checking to see if this is going to equal 3 minus 3. I get 0 is equal to 0, which is a true statement. Okay, part B. This time let's start by distributing the negative on the right-hand side. So I have negative 2x plus 7 is equal to 3 minus 5x minus 1. I'll add like terms on the right-hand side. So 3 minus 1 is 2. So right now I have 2 minus 5x on the right. The left-hand side is the same, negative 2x plus 7. Okay, at this point I'm ready to add something to both sides. I'm going to choose to add 5x. This way the coefficient of my x variable will be positive. So I have 3x plus 7 is equal to 2. I'll subtract 7 from both sides. So I have 3x is equal to a negative 5. So x is equal to negative 5/3. Okay, part C. Here I need to start by multiplying things out. So on the left-hand side, when I FOIL, I'll get x squared minus 3x plus 2x. So I'll add those together to get my minus x minus 6. And then don't forget to FOIL on the right-hand side as well. So remember, this is x plus 3 times x plus 3. So when you FOIL that, you'll get x squared plus 6x plus 9. Okay, so you'll notice that the x squareds cancel, okay, which is why we still have a linear equation. So I have negative x minus 6 is equal to 6x plus 9. I'm going to add an x to both sides of the equation. So I have negative 6 is equal to 7x plus 9. Subtract 9 from both sides. So we have negative 15 is equal to 7x, which means x is equal to negative 15 over 7. We could check this by plugging it back in for the x's. For your homework problems, since you're doing it on MyLab Math, you'll check your answer automatically, which makes it kind of nice. But if it was a situation where you weren't able, if you weren't doing it on the computer and you wanted to check your work, plug this x value back in for all the x's. Make sure you get the same thing on both sides of the equation. Okay, moving on to part D. Here we notice that we have a fraction. So I'm going to choose to clear my fraction. So I'm going to multiply both sides of the equation by 3. Okay, so I need to distribute the 3. I'm distributing over this plus symbol here that's separating my fraction with the number 16. So when I distribute the 3 to the first fraction, I'm simply left with the numerator, which is the 2x plus 1. Okay, so the reason why I multiply by 3 is because I want to cancel it with this 3 that's here in the denominator. Okay, the 3 also gets multiplied by the 16, so we have 48. On the right-hand side of the equation, we have our 9x. Okay, add your like terms. So So we have 2x plus 49 is equal to 9x. Subtract 2x from both sides. So 49 is equal to 7x, which means that x is equal to 7. Okay, so sometimes I skip this last step. So what I'm doing here is dividing both sides of the equation by 7. Okay, so you could write that in if you want to, or you know, if you're doing that in your head, that's fine too. But certainly you're allowed to write down more steps than I do. Some of these you could have done at once, like subtracting the x squared here. You didn't have to write that out. You could have just crossed off the x squared, since you notice that there's a positive x squared on both sides of the equation. Okay, so you do need to show work when you're turning in your quizzes and your exams. Okay, but it doesn't always have to be this much work. I'm just doing it because I know some students do like to see more steps shown. Okay, part E. So again, we have fractions. You can either work with the fractions or clear them. Okay, so let's just go ahead and clear the fractions in this problem. We want to multiply both sides of the equation by the LCD, or by the least common denominator, which is a 6. So I'm going to multiply both sides of the equation by 6, and this will clear the fraction. So on the left-hand side of the equation, I need to distribute, because I have this subtraction symbol here separating my two fractions. 6 times 1/2 is 3, minus 6 times 1/3 is 2, so that I have 3 minus 2p. This is equal to, so on the right-hand side of the equation, I have 4/3 times 6. So 3 goes into itself once, it's going to go into 6 2 times. So on the right-hand side of the equation, I have an 8. Okay, let's subtract 3 from both sides. We now have negative 2 times p is equal to 5. Divide both sides by negative p. Sorry, divide both sides by negative 2, I meant to say. So we'll get p is equal to negative 5/2. Good. Again, you could always plug that back in for the p and make sure you get the same value on both sides of the equation. Okay, moving on to part F. So again, I have fractions here, and I'm going to choose to clear the fractions. This time the denominator is x plus 3. So I'm going to multiply that on both sides. I need to distribute on the right-hand side this time, because that's where the subtraction symbol is. Okay, on the left-hand side, my x plus 3's cancel, so I'm simply left with 2x. On the right-hand side, when I distribute x plus 3 to the first fraction, it cancels with the denominator, so I'm simply left with minus 6. And then when I distribute it to the second guy, the minus 2, nothing cancels, right, because it's just the number 2. So I have negative 2 times the quantity x plus 3. Okay, let's distribute. So negative 6 minus 2x minus 6 add our like terms. So we'll have negative 2x minus 12. I'm going to add 2x to both sides. And then I have 4 times x is equal to negative 12. Divide both sides by 4. And I come up with x is equal to negative 3. Okay. We have to go back and look at the original, so I'm going to erase some of my writing here. The original question has this x plus 3 in the denominator. Okay, so I know that the domain of this expression, so considering either side separately, x cannot equal negative 3 because I can't divide by 0. Okay, so the only number that's not going to work for my solution is negative 3, and that's exactly the number that we came up with, which tells us that this equation has no solution. Okay, and I'm going to cross out that x minus 3. Okay, so we correctly worked through the problem, but we came up with the number that x cannot equal, since we can't divide by 0. Okay, so for these problems, make sure that you are checking your work just to make sure you're never dividing by 0. Okay, back in part E, checking your work, that was to make sure we did everything correctly, but we knew that we were never going to divide by 0 because we don't have a variable in the denominator for part E. Okay. For the next problem, we have negative 4 divided by 2x plus 3 plus 1 divided by x minus 1, and this is equal to 1 divided by 2x squared plus x minus 3. We're going to start by factoring our trinomial, so I'm going to write that here on the right hand side. So we have 2x squared plus x minus 3. What we could do is simply use a guess and check method. The problems in the textbook and in MyLab Math are kind of contrived to work out nicely, right? So notice on the left-hand side, I have a 2x plus 3 and then an x minus 1. So let's just take a guess and see if that's how this guy factors. So I'm going to see if this is equal to 2x plus 3 times x minus 1. So I'm going to FOIL. I get 2x squared minus 2x plus 3x minus 3, which is 2x squared plus x minus 3. Okay, so this works. I figured out how it factors. Otherwise, you're doing your AC over B, right? Air conditioning over basement. Find the numbers that work out, rewrite the middle term, and factor by grouping. Okay, so just be careful. The leading coefficient is the number 2. So anytime the leading coefficient is not 1, you have that extra step when you're factoring. Okay, I'm going to go back to the original, and I'll rewrite it, and I'll write the right-hand side in factored form as I do. So we have negative 4 divided by 2x plus 3. We're adding 1 over x minus 1, and this is equal to 1 divided by 2x plus 3 times x minus 1. Okay, so I multiply both sides of the equation by the denominators. So 2x plus 3 times x minus 1. Multiply that on both sides. On the left-hand side, I distribute because I'm distributing over this plus symbol that's here, separating my two fractions. Okay, so we'll notice that we have a 2x plus 3 in the denominator, and then also we're multiplying by 2x plus 3. So those two will cancel. I'm left with negative 4 times x minus 1. Okay, and then I distribute to the second fraction. This time I have an x minus 1 in the denominator. So the second fraction, the x minus 1 will cancel. I'm left with 1, which you wouldn't have to write. 1 times 2x plus 3. This is equal to, so on the right-hand side, the 2x plus 3's cancel, the x minus 1 cancels, so we're just left with the number 1. Okay, so now our equation's a lot easier to solve. I'm going to distribute the negative 4. So we have negative 4x plus 4 plus 2x plus 3 is equal to 1. Add our like terms, so negative 4x plus 2x is negative 2x. Add the 4 and 3, so we have 7. This is equal to 1. I'm going to subtract 7 from both sides. So we have negative 2x is equal to negative 6. Divide both sides of the equation by a negative 2. So we have x is equal to 3. Okay, so remember, we now need to check this. But the minimum you need to do is check to make sure that we don't have a 0 in the denominator. Okay, so if I look back at my original question, so I'm looking here at what I have in yellow. So I'm trying to focus on just what's here in yellow, the original question. If x is 3, this first fraction is fine because 2 times 3 is 6, plus 3 is 9, so I don't have a 0 in the denominator. The second fraction is also good. Plug in a 3 for x, and you'll have 3 minus 1 or 2. Since on the right-hand side we have the same two factors, we just have 9 times times 2. So we don't get a 0 in the denominator. Okay, so that's good. That means our answer, we've checked to make sure our answer is valid. Okay, so as long as we didn't make any mistakes as we work through the problem, we're good. And then just remember, if this was a test question, what you could do if you have time at the end, plug the 3 back in to the original and make sure you get the same value on both sides. Okay, I think this is the last one that we'll do together. So let's add any like terms. So on the left-hand side, I have x plus 5. On the right-hand side, add our like terms together. So 4x minus 3x is just x, and then 6 minus 1 is 5. So I have x plus 5 equals x plus 5. You might be able to stop here. Otherwise, maybe you subtracted an x from both sides, and then you would have 5 is equal to 5. And so hopefully if you didn't already stop, you would stop here. Okay, 5 equals 5 is a true statement. Okay, which means that no matter what we plug in for x, we'll always come up, it'll always lead to this true statement, 5 equals 5, or the true statement x plus 5 equals x plus 5. That means this is an identity. It's an equation that is always true. So since it is always true, our answer is all real numbers. You can write that out in words. The symbol for all real numbers is a capital R, but with 2 vertical lines instead of 1. So either one of those is fine. Okay, example 2, you're going to complete these and turn them in through Canvas. In part A, you have 5 times the quantity, 2m plus 3 minus 4m is equal to 2m plus 25. In part B, 2 divided by x squared minus 6x plus 8 is equal to 1 divided by x minus 4 plus 2 divided by x minus 2. Okay, good luck. Let me know if you have any questions.